If you deploy a database into Kubernetes like a normal app, you can corrupt your data without realizing it. Not maybe, but eventually. Because database needs three things, which Kubernetes will not guarantee by default: identity, storage mapping, and startup order. Hi, I'm Shivam, and this is the third video of the series, Data and Reality Check. Today, I will prove it on my local cluster in a few minutes. After watching my previous video, a lot of people get confident that I have PVC now. I can run Postgres or MySQL DB on it. PVCs solve just one problem, and that is data survival. But databases are harder because they are not just files on disk. Instead, they are systems. They have master-slave relationship, read-write replicas, stable node membership, and controlled bootstrap. So let's head on to the demo section and we will see this in action. So this is my current cluster. I have one control plane node and two worker nodes. Let's go ahead and we'll create our first deployment. As you can see, the kind is deployment. The name of the deployment is db deploy. It has three replicas. It is running a busybox image. Nothing fancy, just simple deployment. Let's apply this deployment. So here I have opened another terminal where I'll be watching the pods once they are created. So let's apply our deployment. And we can see all our pods are up and running. If you look closely at these pods, they have random names. So the first part is the name of the deployment, and these are random hash values. Similarly, notice the IPs. They are not stable. Once a pod is restarted, it will get a new IP. Now let's try to delete a pod. So our pod is getting deleted, and we can see here on the other terminal that our pod got deleted and a new pod is up and running. So let's wait for this pod to be fully terminated and we'll run the get pod command with -o white flag again. So our pod has been deleted. Notice something here. We deleted the first pod. A new pod was replaced with a new name and a different IP address. So for stateless app, this is perfectly fine. But for a database, it is dangerous because database thinks in terms of member nodes. If identity changes, membership breaks. This is the first trap. If your database expects node 1 is node 1 and master node is master, a deployment cannot guarantee you that. So Kubernetes gives us a tool built for stable identity, and that is called StatefulSet. Let me clear this, and we will create a headless service plus StatefulSet. So I have already written the configuration for headless service and StatefulSet. Let me copy that and we will go over it one by one. So as you can see, this is a headless service. The kind is service. The name of the service is DB. And if you see the selector, it exactly matches with the label mentioned in our stateful set. So let's look at the stateful set. We can see the kind is stateful set. Name is DB. It has three replicas. It is using a service name what we created above, which is DB. And it is using a busybox 1.36 image. So once again, a stateful set is like a deployment, but for stateful apps. It gives each pod a stable identity, its own storage, and starts them in a predictable order. So even if a pod restarts, it comes back with the same name and the same data, which is critical for database. So let me go ahead, save this, and we will apply this stateful set. So it says our service and stateful set has been created. Let's check our pods. So we can clearly see that the new pods have a stable identity compared to the previous one, which uses random hash value whenever a pod is restarted. Now let's try to delete one pod and we'll see how it comes back. So our pod has been deleted. Let's check them again. You see here, it came back as db1 again. Same identity and predictable manner. Now let's try to explore the DNS. So here I am using nslookup command, and this is the full DNS name. So db1 is our pod name, .db is the service name which we created earlier, default is the default namespace, and svc.cluster.local. This is how database find each other reliably. Now we will look at how StatefulSets stores data in a reliable manner. Till now we have looked at deployments and StatefulSets, but now I will prove you the second trap. Even if data persists, the wrong pod attaching to the wrong disk is a disaster for database. And StatefulSets solves this issue by creating one PVC per pod using VolumeClaimTemplate. So I have already written the YAML configuration file for service, StatefulSet and VolumeClaimTemplate. So let me copy that and we will go over it. As you can see, the kind is service, the name of the service is DBS, but remember previously we created a service named DB, but now we are creating DBS. Similarly, this is the selector for our stateful set. Here the kind is stateful set. It has 3 replicas. Service name is DBS. It is using a busybox 1.36 image, and this is the volume claim template which I was talking earlier. If you look at this declaration, it looks very similar to the PVC configuration what we discussed in our previous video. So it has access mode of read write once, and it is requesting 100 MI storage. So volume claim template automatically creates a separate PVC for each pod in a stateful set. If you remember my last video where we discussed about persistent volume, there the hierarchy was first we have to create a persistent volume, then we have to create a persistent volume claim, and then we have to attach that persistent volume claim to a pod. But here we are not creating any persistent volume or persistent volume claim. Volume claim template automatically creates a separate PVC for each pod in a stateful set. Unlike normal volumes, they are shared or manually created. This ensures every pod gets its own dedicated storage. So in our case, DBS0, DBS1 and DBS2 each will get their own disk that stays attached even after these pod restarts. And if you look closely here, I'm attaching this claim at /data directory inside the pod. So let's go ahead and save this file and we'll apply our template. So it says our service and stateful set has been created. Let's explore that. So our pod is now up and running. Similarly, let's try to explore the PVC also. You see here, we did not create any PVC, but these PVC are still bound to our pods. And each of them is having 100 MI of storage with access mode equals read write once. These all things we declared in our ststb storage.yaml file inside stateful set configuration. Now let's try to exec into each of the pod, and we will try to create a file called id.txt and we'll put some data in it. So in order to save some time, I have already written the command for that. I'm just going to copy paste it here. As you can see, this is kubectl exec minus interactive terminal. This is the name of the pod, and this is the command which I am running. So it says echo imdbs0, then redirect it to a file which is id.txt located inside /data directory, and then I am just printing out the contents of the file. So our files are created now. Let's try to delete these 3 pods and we'll see what happens. So as you can see on the second terminal, our pods are getting deleted. Let's wait for all the 3 pods to be deleted and recreated successfully. So our pods has been deleted. Let's verify them once. So all the new pods has been created. If you see here, one was created 74 seconds ago, second was 44 seconds ago, and the third one is 13 seconds ago. Now again, let's try to exec into all the pods and we'll see if our id.txt file exists or not. I'm again using the same command and you can clearly see that even though our pod was deleted or restarted, our data still exists in the same directory. So this proves that each pod got its own PVC and it came back with the correct data even though we deleted the pod and the new pod was created. So this is the key database requirements where identity and storage must be glued together. Now I'm gonna scale my stateful sets to 5 replicas and we'll see the ordering. So it says replicas has been scaled. Let's check our pods. And you see here it is trying to create the 4th pod and the 5th pod. So all our pods are up and running. Now you can see here that it creates them in order. The third one came after second and the fourth one came after third pod. Database often needs this because leader must exist before replicas. Bootstrap must finish before joining. A deployment will happily start everything at once, as we have seen that in our previous videos. But a stateful set gives you a predictable startup. So here's the truth. PVCs help your data survive, but database needs more than just survival. They need stable identity, stable storage mapping, and predictable ordering. Stateful sets gives us these primitives, but it's still not click, deploy, and forget. Kubernetes isn't magic, and this is where people get confused. Because on our laptop with Minikube or Kind cluster, everything feels easy. Then we go to production and suddenly networking behaves differently, storage behaves differently, and most importantly, security rules hit you. In the next video, I will explain exactly why Kubernetes feels easy locally but hard in production. Minikube versus cloud, networking, storage, and security. Because the cluster didn't get worse, but the reality did. See you all in next video. Till then, keep learning.